Let's do a problem from your lab assignment from section 5.1. Find the sum of the infinite geometric series. So we have an infinite geometric series, a series that has a constant times some value raised to the nth power, where n is the index going, in this case, from 0 to infinity. So the geometric series formula tells us that we need to figure out the first term of the geometric series and then figure out that ratio. So the first term of the geometric series, when you put 0 in for n, it's going to be 8 times 0.75 to the 0th power, but 0.75 to the 0th power is just going to be equal to 1. So our first term is 8. I have to warn you that if this n does not start with 0, then your first term is not going to be 8. So always look out for the first term, whatever the first term is. Once we have that, we found the common ratio. We'll find the common ratio. If you take a look at the thing that's being raised to the power, that's usually going to be the common ratio. So we'll go ahead and put 0.75. Based on your results from part 1 and part 2, the sum of an infinite geometric series formula may be applied to this series. What guarantees a formula will work in this case? The first term has an absolute value greater than the common ratio. Well, it turns out that the first term doesn't really matter, so that's not a good reason for that, for selecting the geometric series formula. The common ratio is less than the first term of the series. I don't think that's the right one either, because we're not comparing the common ratio with the first term. The common ratio has an absolute value that is less than the first term in the series. That's not what we want either. The common ratio has an absolute value less than 1. I think this might be it, but let's take a look at the other two options. The first term of the series is positive. That's not necessarily true, or that doesn't have to be true for it to be to work. And then the first term of the series has an absolute value less than -1. Again, we don't care about the first term in the series. This could be negative, this could be bigger than 1, less than 1, whatever. It doesn't matter. So this geometric series formula works when your R value, and this is one way to write it, when your R value is between -1 to 1. Another way to write this is to say that the absolute value of R is less than 1. And so if that's true, then this formula can be applied. So we'll say that the common ratio has an absolute value less than 1. It's equal to 0.75. And so we compute the sum. So this is the sum that we want to use. This is the formula that we want to use. So we'll use that formula to make our computations, and then we'll put in the first term. The first term was 8 in our problem, and then the ratio, the common ratio, was 0.75. So if we figure this out, 8 divided by 1 minus 0.75 is 0.25. So that's like 1/4, and 1/4 times times 8, or 8 divided by 1/4 is like saying 8 times 4, the reciprocal, so that should be 32. Okay, so I hope that helps. Good luck.